Hi everyone. Today we're going to discuss allocation and lifecycle assessment and how to do it in CarbonGraph. When a single production process yields more than one final product, we refer to these outputs as co-products. A classic example of this is milling wheat into flour and bran. The question we use allocation to answer is, how do we fairly divide the total environmental impact among these co-products? In an ideal world, we try to avoid allocation by subdividing the processes or using system expansion methods. But when that's not possible, we turn to allocation, distributing the impacts in proportion to some property of the products. There are different ways to do this. Two of the most common approaches are physical allocation and economic allocation. Physical allocation apportions impacts based on a physical property, like mass or protein content. Economic allocation apportions impacts based on market value. Today we'll focus on economic allocation and show you exactly how to set it up in CarbonGraph. Let's say we have 1 kilogram of wheat. Milling that 1 kilogram of wheat results in 700 grams of flour and 300 grams of bran. We also know that, in total, 1 kilogram of wheat has an impact of 610 grams of carbon dioxide equivalent, and milling requires a little bit of electricity. So why are we choosing economic allocation? Suppose that 95% of the total value from these co-products comes from flour. Bran is much less valuable by comparison. Because our LCA model is focused on flour, we need to attribute its portion of the upstream impacts accordingly. Let's illustrate how this works in CarbonGraph. First, we define a milling process that outputs 1 kilogram of wheat flour and bran, which actually consists of 700 grams of flour and 300 grams of bran. Since we're only focusing on the impacts associated with the flour, we need to add our allocation step. Since we've chosen economic allocation, we specify that 95% of the product's economic value, or 0.95 kilograms worth of the 1 kilogram of impact, is for flour. And we specify that it's 95% of the impact being attributed to 700 grams of flour. CarbonGraph will automatically calculate how much of the impact belongs to the flour. To finish, we have one more step. We want to know the impact per kilogram of flour, not per 700 grams. Under this setup, almost 580 grams of carbon dioxide equivalent is attributed to 700 grams of flour, while 30.5 grams of impact would be assigned to the 300 grams of bran. To figure out the per kilogram impact, CarbonGraph automatically calculates 579.5 grams of carbon dioxide equivalent divided by 700 grams is equivalent to 828 grams of carbon dioxide equivalent per kilogram of flour. Now, whether we use 1 kilogram or 100 kilograms or any other amount downstream, we have the correct impact for our flour. To recap, co-products like flour and bran arise from the same process. We often try to avoid allocation, but when needed, we can use physical, economic, or other methods. In this example, we used economic allocation because flour has a much higher market value. We ended up allocating 828 grams of carbon dioxide equivalent to each kilogram of flour produced. Thanks for watching. We hope this gives you a clearer sense of how and why allocation is used in LCA and how to set up an economic allocation step in CarbonGraph. If you have any questions about other allocation methods or advanced modeling in CarbonGraph, feel free to reach out. Subscribe to this channel for more CarbonGraph modeling tips and LCA tutorials.